Hello, welcome to the solutions video for Pre-Cal worksheet 1.10. So our first three, we are to find the domain. So we really care about the denominator here. Where does the denominator equal to 0? So what I'm going to do on number 1 here is factor the denominator. So we have x. I need a 2 in the middle, and 7 times 5 is 35. So let's put a 7 and a 5 there. And let's see, I need a minus 2. So let's make the 7 negative and the 5 positive. All right, so nothing cancels. So what two values would make the denominator 0? Well, we would set the first parenthesis, x minus 7 equal to 0. So x could not be 7. And then for the second parenthesis, x couldn't be negative 5. So what this is saying is that our domain is all real numbers except 7 and negative 5. And I don't care about the order of these. Some teachers would make you put the negative 5 first. I really don't care about that. All right, on number 2, so let's take a look at the denominator. We could factor out a 3x, and what's left would be 3x minus 1. So there's two values that would make the denominator 0. If you're not sure about this, just take each section and set it equal to 0. So we would set 3x equal to 0, so x is equal to 0 there. And we could set 3x minus 1 equal to 0. 3x is equal to 1, so x would be 1/3. So our domain is x cannot be, or our values that we're excluding from the domain, 0 or 1/3. So the domain is all real numbers except those two. Those are the two numbers that if we plug them in to the denominator would make the denominator 0. All right. So for this one, we can go ahead and factor out the top for practice, but we're really worried about the denominator, okay? What numbers would make the denominator 0? And you could probably eyeball that. But if we factor an x out of the top, would be x squared plus 4 would be left. Now, on the bottom, that's actually the difference of two perfect squares, where a is x squared and b is 1. So that would factor into x squared plus 1 and x squared minus 1. Well, x squared plus 1 could never be 0. So what numbers would make this right parenthesis 0? Okay, well, it's going to be plus or minus 1. Positive 1 would be 1 minus 1. And then negative 1 squared is also 1. That's 1 minus 1. So x could not be, if you want to write it this way shorthand, you can write plus or minus 1. So the domain is all real numbers except those two. All right, number 4, we want to divide 6. I'm going to write that as 6 over 1 by 2/7. So we're going to take the denominator and flip it, and then we can multiply. So if you want, you could cancel out that 2 and make it a 1 and make this a 3. 3 times 7 is 21 over 1. And that is just 21. Okay, so number 5. So I'm going to write this as negative 7 over 4 divided by 4 over 7. So that's going to be negative 7 over 4 times 7 over 4. That would be negative 49 over 16. And that will not reduce anymore. All right, number 6, we have 3x over 5 minus 2x over 15. So I need a common denominator here. So I can do that if I multiply the first term by 3 over 3. So that would give me a denominator of 15 in this left term. So then that would be 9x over 15 minus 2x over 15. And then we can just subtract the top. And that's going to be 7x over 15. All right, number 7. We have 3y over 4 plus 5y over 24. So to get a common denominator, I could multiply this first term by 6 over 6. And then that would give me 18y over 24 plus 5y over 24. And that's going to be 23y over 24. And we really can't reduce that anymore. All right, number 8, we want to simplify. So we've got 5/3 times negative 9 over 20 minus 2/7 times negative 7 over 3 minus, and this was a minus, not times, 1/6 times 2/3. So I'm going to see, instead of just straight up multiplying this out, let's see if we can reduce a little bit. So 5 will go into 24 times, so we could reduce that to 1 over 4. And we could reduce this into 1 over, or negative 3 over 1. Right, 3 goes that negative 3 times. Here, this would be a negative 1, and the 7 would cancel out there. And we can do a 1 and a 3 here. So let's go ahead and rewrite this in reduced format. So I'd have negative 3/4. So 1 times negative 3, 1 times 4, minus, and that'd be negative 2/3, because this was a 1, right? And then minus 1/3. Okay, so I still, doesn't really help all that much. Let's see, minus 1/9. I'm sorry about that. 3 times 3 is 9, so minus 1/9. Okay, I think a common denominator of 36 would work, because 9 times 4 is 36, and 3 will also go into 36. So let's multiply this first one by 9 over 9. And the second one, 9 times 4, 12 over 12. And then the third one, 4 over 4. All right, so that would get us all in terms of 36. So that's going to be, that is a minus sign there. So that's going to be negative 27 over 36 plus, because 2 negatives make a positive, 24 over 36 minus 4 over 36. Okay, so we've got negative 27 plus 24 would be negative 3 minus 4. So that's negative 7 over 36. So that one was a little bit of a pain in the caboose. But, you know, if you got it right, give yourself a little pat on the back. Pretty cool. let's go ahead and do the last four. So number 9, we want to simplify. X plus 2 over x squared plus 5x plus 6. All right, that's x plus 2. Let's factor the bottom. So see if we can factor that. So that would be x, and I'm thinking of plus 3 and plus 2. Would, if you FOIL that out, you get back to there. We can go ahead and do our domain restriction now. So x plus 3, x can't be -3 or -2. Either of those values would make the denominator 0. So you have to write that in. That's part of the answer. Then the x plus 2's will cancel, and you're left with 1 on top over x plus 3. All right, so that's pretty cool. Number 10, we've got x squared plus 2x minus 15 over x squared plus x minus 12. Okay, we're going to try to factor both the top and the bottom. The top, we would have an x and an x, and 5 times 3 is 15, and there's a difference of 2 between 5 and 3, so I'm going to put a 5 and 3 there, and it needs to be the bigger number needs to be positive. That'll give me a positive 2 when I FOIL that back out. And the bottom, we have x, x, and 4 times 3 is 12. We need a positive 1 in the center, so that'd be a plus 4 minus 3. So I've got two values that x can't be, or it makes the denominator 0. -4, because -4 plus 4 is 0. And then positive 3, because 3 minus 3 is 0. So you got to put those in. Then we can cancel out the x minus 3, and we have x plus 5 over x plus 4. All right, that's cool. Only 2 more to go. Number 11, we have x cubed plus 1. All right, we're going to have to remember a formula here. Over x squared plus 7x plus 6. So that x cubed plus 1 is actually the sum of two perfect cubes, where a is x, right? And b is 1. So that would factor into x plus 1 times a squared, so that would be x squared minus ab, so that's 1x, and then plus b squared, so plus 1. And then the bottom is just a garden variety factor of a trinomial, so x, and to get 7, it's going to be plus 6 plus 1. That'd give me that 6x plus 1x, or 7x in the middle. So we've got two values x cannot be, -1, because that makes this parenthesis 0, and -6. So make sure you include those. And then to simplify, we can cancel the x plus 1's out, and we'd have x squared minus x plus 1 over x plus 6. So you may not think, well, that's not much simpler than the beginning, but the way it's simpler is that we went from a cube value to a squared value, and mathematicians consider that a simplification. All right, finally, number 12. I think I'm going to erase here for number 12. It'd take up maybe a little too much space to smush into my little bottom area there. All right, 12, we've got 2a cubed minus 54 over 2a squared minus 18. Remember, when we factor something, the first thing we want to do is factor out a greatest common factor. So if we factor a 2 out of the top, we'd have a cubed minus 27. And if we factor a 2 out of the bottom, we would have a squared minus 9. All right, now those 2's go away. Okay, so now we would just have a cubed minus 27 over a squared minus 9. Well, this is the difference of two perfect cubes, where big A is A, and B would be 3, right? 3 cubed is 27. This is the difference of two perfect squares, where A is A, and B would be 3. So this is going to factor into A minus 3. All right, so we're doing the top here, times A squared plus AB, so that would be 3A plus B squared. B is 3, so that'd be 9. Over the difference of two perfect squares factors into A plus 3 times A minus 3. Now we can get our domain restriction. A cannot be what numbers? Well, it can't be negative 3, because that would make this parenthesis 0, and it can't be positive 3. That would make that parenthesis 0. And you have to put this to get all the credit. And then A minus 3 would cancel, and we'd have A squared plus 3A plus 9 over A plus 3. All right, fun. I like that kind of stuff. All right, so hopefully this solutions video helped you. I'll talk to you on the next one.